Hi there, everyone. So like I said in my email, my kids are sick and I have to stay home with them. So this is not ideal here, but I think sending out a video and letting you watch it at your leisure tomorrow is maybe better than trying to hold Zoom classes, especially towards the end of the semester when everybody is getting kind of tired and so on. So anyway, so the point of this video was to cover section 13.1. Now we're almost done with our material. The last little bit of material that we're going to cover is called descriptive statistics, like a sort of introduction to the language of descriptive statistics, which includes things like mean, median, mode, standard deviation, just sort of basic ways of describing data. That it's good to know that language and to know what is being communicated to you when other people use that language. So anyway, we're going to spend just 3 days doing some introductory descriptive statistics like mean and standard deviation and maybe some linear regression, and that'll close out the end of the semester. And when I come back to class on Monday, we'll talk about things like your exam last week, the final exam, and things like that. So anyway, for now, we're just going to cover section 13.1. So the handout is on Moodle. As always, here we go. As always, you can follow along in the handout, which I'm going to bring up now. Okay. So hopefully everybody can see that. Okay, so what's the point of this section? Talk about how you measure the center of a numerical data set is the point of this section. So this section involves terminology that most of you have heard and probably know already. But the terminology is mean, median, mode, and weighted mean. So those are the things we're going to cover that you should be able to do by the end of this video. So just a brief overview. I mean, after any of your exams, when I come to class, I give you the average or the mean, whichever word you want to use, and the median. And the question is, why am I telling you that? Like, what kind of information is that conveying to you about the numerical data set that makes up your exam scores? And the answer is, I'm giving you a sense of sort of the center of the data, central tendency. So what I'm trying to communicate is how a sort of typical score looks like, how a typical student did, so that I guess you can compare yourself to the center. Now, it's not clear to me that I should do that, by the way. It's not clear to me that sharing means and medians of exam scores is good, but students always ask for it, so I do. Okay, so let's start with mean. What is a mean? Mean, in colloquial language, people say average, so I'll probably slip and use both terms. It doesn't really matter. The technical term is mean. Average is a more global term, so an average can be a median. A median is a kind of average, and a mode is a kind of average. But anyway, in colloquial speak, mean, whoa, please stop. Mean and average mean the same thing. Okay, so let's start with the average. So given a set of numbers, the mean is calculated by adding up all the numbers and then dividing by the number of numbers in the data set. So in this first example, what is the mean? Well, we take 42,500, add it to 41,000, add it to 49,000, and so on, dot, dot, dot. I don't think I need to write all these out. And divide by the number of numbers. In this case, there are 8 of them. So you add up all the numbers, divide by 8, and what you will get is, I have it written somewhere, 48,875. So that's the average teacher salary. So again, why would you report that number? You're trying to communicate something about what a typical teacher makes in this data set. So for these 8 teachers, you're basically saying this is kind of like the middle number, the typical outcome, the central salary, something like that. So on average, among these 8 teachers, the average salary is close to $50,000. So that's the idea of an average. And again, I think most of you already know this. If you don't, this is what you're doing. You're adding up all the numbers you see and then dividing by the number of numbers to try to get at the center of the data. So a median is another way of trying to get at the center of the data. And to find a median, what you do is you always list the numbers from smallest to biggest. You always have to do that. And let me make sure I don't mess this up. 42,500, 46,000, 47,500, 48,000, 49,000, 51,000, and 66,000. So you list the numbers from smallest to biggest, and the amount of numbers in your data set is either even or odd. In this case, we have an even amount of numbers. So what you do is you find the two middle ones. These are the two middle numbers right here, the two numbers in the middle. And to find the median of the data set, you take their mean, the mean of the two numbers in the middle, like this. So the mean of those two numbers is 47,750. So again, both of these numbers are getting at, or trying to get at, the center of the salary data. So trying to tell you what a typical teacher makes. Now notice in this example, they're not the same, and the mean and median are often not the same. I'm tempted to say almost never the same. So the question is, why is there a difference, and what is that telling you? So the fact that the average here is bigger, right? That's roughly 49,000. This is roughly 48,000. So the mean is what? Slightly over 1,000 larger than the median. Why is that? And the answer is, if you look at this teacher data, oh, sorry, on the one you have, I should have noticed this earlier. This is 66,000. I don't know why I have an outdated handout in here, but anyway. Okay, it doesn't matter. Sorry, I should have checked that I had an updated one here. But anyway, when you're taking an average, an outlier can have a large effect. So if you don't know what that term is, an outlier means a number that's not really close to the other numbers. So this one teacher making 66,000 is making pretty fat cash compared to the other teachers. Most of the salaries are in the 40,000 range. Then you get a single salary that's in the 50,000 range, but it's low. And then all of a sudden you jump up to like the mid 60s. So whenever you have a gap like that in the data, the upper numbers or the lower numbers, depending on which side the outlier is on, will pull the average up. Whereas with the median, the single outlier up here has no effect on the median. So what if I change that 66,000 to like a 79,000? The median don't care. The median only cares about the literal middle of the data. I mean, this teacher could be making $1 million. Okay. And the median won't change. The average will change quite a bit. If I put $1 million up here in this average calculation, it's going to make a big difference. So anyway, what do you notice? You notice the median is smaller, and the reason is what I just said. Whenever you have outliers, numbers that lie sort of out of the typical data, it'll pull the mean, but it won't pull the median so much. So here's another example like that. So you should always be careful when people report to you mean or median, things like household income or home price values, things like that. Because if you think about what family incomes look like, it's going to look like this. So, most people make like a household income, family income, maybe like $70,000. It's sort of a typical family income. However, there are people over here who make like, $800,000 a year. So because there are people who make so much more than sort of where the data is clustered, the data is mostly clustered around here, $60,000 to $90,000, something like that. But wealthy people who make this amount will take the mean and pull it. So look at this. The mean salary is almost $69,000, but the median family income is only $52,000. So again, the reason you're seeing that is because of these higher income people. They're these outliers relative to the rest of the data. So a median, in my mind, is slightly more concrete than a mean because I know exactly what it's telling me. The median is right in the middle. So here, this 52,000 number, what that's saying is half of the families make less than that and the other half make more than that. It literally cuts the data in half. Whereas this is not literally cutting in half. It's trying to point to the center, but again, the wealthier people sort of pull it. So anyway, you can write something like what I just said to answer this question. Of course, if we were in class, you would be doing this and not just listening to me talking sadly to myself on a Zoom meeting that's being recorded. But you can say something like this, relatively few wealthy families are outliers that pull the mean up. And again, this few might not be literally 5 families, but just relative to the rest of the data, relatively few wealthy families, family incomes can now pull that mean up. Okay, so we've covered mean and median. Now let's cover mode. Everybody likes the mode, by the way. If you're asked what a mode is, or if I give you some numbers on an exam and say, what's the mode? Students like that. So the mode is the number or numbers that occurs most frequently. If every number occurs exactly once, then there's no mode. So back up here with the teacher salaries, every number occurs exactly once. There's no repetition of numbers, so no mode. With a data set like this, though, 10 is repeated, 16 is repeated, nothing else is repeated. So this data set has 2 modes, 10 and 16. If there were another 16 at the tail end, the mode would be 16 because now that occurs the most and it's not tied with anything else. Okay, so that's the idea of a mode. Modes in like the statistical literature and things like that are not usually reported that much because if what you're trying to do is point to the center of a data set, I mean, imagine a data set like this. Just whatever. Okay, so a data set like this, I mean, the mode is 10, but 10 is in no way the center of the data. So I don't see modes reported all that much when I read statistics stuff, but it's in your book. Some people like to use it depending on the context. Okay, so mean, median, mode. Those are the first 3 things you should be able to do. If I give you a list of numbers like this, you should be able to calculate the mean, the median, and the mode. And remember, the most common mistake on medians is not putting the numbers in order. So you must order them like this, from smallest to biggest. And then you find either the middle number. If there's an odd amount of numbers, there will be a middle number, or the average of the 2 middle numbers, like we did. Okay, so now the final topic is a weighted mean. And that's when you take a mean, but some of the data values in your set are worth more than others. And this is a concept that's very familiar to you as students, or should be very familiar to you, because when you calculate course grades, a test grade counts more than like your homework grade. And your final exam grade often counts more than a test grade. So you don't just like average together everything. You have to weight things. And GPA is the other classical example for students. With a GPA, an A in like a 5 credit hour class just isn't worth what an A in a 2 credit hour class is. They have different weights because of the different credit hours. Okay, so when you take a weighted mean, what you do is you multiply each number by its weight and then divide by the total weight in the system. So in an example like 6, what you do is say, okay, the student has a homework grade of 92, and that has a weight of 15%. So I'll just multiply by its weight of 15. And then the student got an 80 on an exam worth 20, an 89 on another exam worth 20, 73 on an exam worth 20, and then a 91 on an exam worth 25. The total weight in the system is 100 for the 100%. If you calculate this out on your calculator, you get 84.95. So that student's overall grade is a solid B. So that makes sense. The student got a couple of A's, but they were low A's. and then got a low C. So when it all comes out of the wash, what you'll get is a B. Anyway, this example exists to illustrate a weighted mean. You don't just take the average of the 92, 88, 89, 73, 91. You don't just average together those 5 numbers because they weigh different amounts. So you take a weighted average of those 5 numbers. Let's look at another example or a couple of examples involving GPA. So as I think you know well, an A is worth 4 points. I mean, we have A plus, A minus, B plus, B minus. In this example, we're keeping things simple and not worrying about pluses and minuses. But in a traditional GPA scheme, A is worth 4, B is worth 3, C2, D1, and F0. At Joule, almost all the classes are 4 credit hours. There are some exceptions though. And so usually when you calculate a GPA, you have to take those credit hours into account. Okay, so this student here, they got an A in English. Whoa, an A in English, that's worth 4 points. What is happening? 4 points. A B is worth 3 points. A C is worth 2 points, and that D is worth 1 point. So if you're sort of naively trying to calculate a GPA, you could be like, okay, well, I'm going to average together their grades and get a GPA like this. What is this? This is 2.5. So again, you could just say A is worth 4, B is worth 3, and so on. I'm just going to average those 4 grades and get a GPA of 2.5. However, you cannot do this because again, this A in English with 4 credits is worth more than the D that has only 2 credits attached. So when you're taking an average, you need to weight that 4 more than you weight the D. Okay, so let me come back here and erase everything. So that A has a weight of 4 for the 4 credits. The B also has a weight of 4 for the 4 credits. The C has a weight of 3, and the 1 has a weight of 2. And the student took a total of 13 credit hours. So their GPA is not 2.5, it's a 2.77. So recall that 2.5 was just the mean without weighting anything. So the student's GPA is better than that, compared to this. Why do they come out with a 2.77 bigger than a 2.5? Well, because their 2 best grades, the A and the B, occurred in the courses of more credit hours. So they got weighted more, and so they sort of won out over that D and C. Okay, let me show you one more example, then we'll wrap it up. Okay, so a student has a GPA of 2.3 based on 56 credit hours. So the student has finished 4 semesters and has a GPA of 2.3. In her 5th semester, she does pretty good. That GPA is a 3.75 based on 16 credit hours. So the question is, after her 5th semester, what's her GPA? And again, you don't just want to do this. You don't just want to say, oh, I see a 2.3 GPA. I see a 3.75. So I'll just average them, and her GPA is now this. You can't do that. The reason is because this 2.3 has 56 credits attached to it, and this 3.75 has only 16. So the 2.3, unfortunately for the student, is worth a lot more in the average. So you gotta, again, weight things. And the student has taken a total of 72 credits. That's the total weight, and you get 2.62. So, let me clear all this stuff out. So they had a 2.3 GPA and they did manage to raise it. So that's good. They raised it by like 0.3 points, but they didn't raise it all the way up to the 3. Because again, this 3.75, while good and impressive, only has 16 credits attached to it, in contrast to the 2.3, which has 56. Okay, so that is the end of this section, mostly vocabulary, and vocabulary that, again, many of you know. These examples are what you'll see in your homework, but let me scroll back up. The learning goals for today, which I claim we've done: given numerical data, calculate a mean, calculate a median, explain the differences between the two, why a mean might be way higher or way lower, depending, than a median. be able to calculate a mode, and then given problems like we have below, be able to calculate a mean that where the values are weighted by some sort of appropriate weights. Okay, so unshare this. Stop. Okay, where am I at? Okay, now I see myself. Okay, so again, this is not ideal. If you have any questions on any of this, please feel free to shoot me an email. If I don't hear from you or whatever on Monday, we're just going to pick up right where we left off. We're going to do section 13.2, which is about the standard deviation and measuring spread in data instead of measuring the center. But as always, if something bothers you, make sure you shoot me an email. The homework is posted. The homework looks just like this, so you can try it out and see if you have any issues. And if you do have any issues, again, make sure you let me know. There is no paper homework over this section because it's like all computational. There's really nothing I can add to the WebAssign in terms of feedback. So there is no paper homework. There's no more paper homework for the semester because we're done. So again, if you have any issues with the WebAssign, please let me know.